Assalamualaikum and very good mornings to our lecturer Puan Nur Hikmah. So my name is Muhamed benci Nawi. My register number is 01DSB18F2020. I'm from class DSB4A. So today I want to share about my case study from environmental science, who is passive building and green buildings. Let's check out. Okay, my building is Tata Energy Resources Institute at the India. So the site location is 30 kilometers south of Delhi in northern Haryana at Guwahati. So the site content is forestry, micro progression technology park (MTP), Pachi Greens Retreat Center and golf range. So the site area of the Tata Energy Resource is 36 hectare. The climate is composite. The building type is institutional. The architect is Sanjay Parkesh and Terry. So the year of the start project is 1997 until 2000. So the cost of technology is 19.54 million. So the biodata architect is Sanjay Parkesh, born at 10 March 1924. So his award is Indian Institute of Architects Gold Medal. So this shows that this architect built the amazing Tata Energy Resource Institute to shows the green building and passive building at the Tata Energy. Okay, let's talk about green building and passive building. What is a green building? Green building refers to both structure and the application of processes that are environmentally responsible and resource efficient throughout a building life cycle, from planning to design, construction, operating, maintenance, renovation, and demolition. What about passive building? Passive building is a design that takes advantage of the climate to maintain a comfortable temperature range in the home. It is achieved by appropriately orientation your building on its sides and carefully design the building envelope, roof, walls, window, floor of a home. Why I choose this building? So I have a reason why I choose this building. Because this building, Tata Energy Resource Institute, use less energy, water, and natural resources. Number 2, they also can generate less waste. Okay, they also can give healthier for people living on it. Number 4 is they have research and save energy with 30 until 40% per day. Another that it can enhance indoor air quality, light and ventilation, can potable water saving up to 20 until 30%, and the last one is minimum generation for non-degradable waste. So that why I choose this building, Tata Energy Resource, for my case study. So we go through on the geometry of the block. So as we can see, the Tata Energy Resources. So the north block is made slightly concave toward the front. South forms a hybrid convex surface facing the winter sun. So the point of the south block broadly falls on the surface of large imaginary cones that generate the slightly free geometry, and this allows the architecture to break away the grid iron approach normally associated with solar architecture. So we go through at the site and design. So they use linear geometry of the site with a narrow frontage and aspect ratio of almost 1:3. Dictates the strong linear axis in the design. So the positioning, the three distinct functioning zone in hierarchy. So they use 3 functioning zones. That placing the commercial block in front, commercial block at the front, in exploiting the commercial potential of the frontage of the site. So the residential zones come up from the rear, forming at the last zone in the linear sequence. That's the design response to orientation and the climate factors. The nose line is at a slight angle to the linear axis of the site, and the design take full advantage of this orientation in the composition of the build and open space and in creating wind flows through the complex, as also lighting and shading of the space. So we can see the site plans that has hostel, classroom, court, laboratories, open air tree, administrative block, and dining hall. The element of design is the sun, sky, air, water, and earth. Shape, the nature of architecture which emerge on the site. The process of continuous dialogue between the architect and theory, and the engagement of theory in the design process has augmented the trust on climate responsive design in a large way. Okay, for the first is the sun. So the passive solar design is an important feature in the design of this building. All the linear blocks are oriented in the east-west direction with shorter facade facing the sun. Most of the southwest facing walls are kept blank in order to protect the building from the harsh southwest solar radiations. Where the southwest walls have openings, they are protected by means of pergolas or projecting balconies. The east, west, and south facade of the building have minimum glazing. Okay, number 2 is air ventilation. So for the air ventilation, the predominant wind direction is taken into account in designing the open space. The central atrium acts as an air funnel defined by the other buildings. The opening oriented in the prevailing wind direction catch the outside air and channelize it through a narrow stretch of the block before releasing into the central court area. The architect's experience of design in hot dry areas made him confident of the effectiveness of this design feature in cooling the ambient temperature of the enclosed area. The central atrium is also proposed to be covered with an automatic adjustable lever system pergola. As you can see, the picture of the lever system pergola. So next, the angle of the levers can be adjusted to block the solar radiation during summer and to allow ample sunlight during winter. And the last one, the lever, if kept closed, can effectively prevent rainwater from entering the atrium during the rainy season. As we can see, there are many of like adjustable lever system function that can shows the passive buildings at the Tata resources. Okay, next is the sky. So the sky maximum use of daylight and use of light sensor to regulate the use artificial lighting in the interiors is another key design strategy. So in areas where daylight is available, fixtures have been fixed with continuous dimming electronic ballast. These fixtures are controlled by light sensor which respond to available light condition and automatically regulate the reconnect fixture to achieve the desired level of uniform illumination required. In areas with non-uniform illumination, occupancy sensor that can turn off the light when the space is unoccupied have been installed. This kind of the lighting system has an potential of saving 70% lighting energy demand. Use of efficient double glazing window units help significantly reduce the heat gain through window glazing in the summers and the heat loss in the winters without compromising on the daylighting integration and the levels of visual comfort. Okay, we can see the that shows the picture of smart window. The double glaze facade reduce heat gain. Okay, so the daylighting integration using light features responding to available natural light and adjustable aero screen levels to regulate summer and winter sunlight entry at the top and center. Okay, next is water. Water being a water starved area, incorporation of water saving features and rainwater harvesting was an important concern in the design brief from the very beginnings. All buildings in the campus of Tata Researchers have been provided with low flow features such as dual flush toilet, low flow taps and sensor that the result in 25% saving in water use. The wastewater generated from the hostel block is treated through efficient biological process using combination of microorganisms and biomedia filter. This treatment system requires less area and low energy. The treated water meets the prescribed standard from landscape irrigation. Rainwater harvesting is also an important concept which contribute to efficient water management. Rainwater run off from the roof and the side are tapped to recharge the aquifer. This enhances the sustainable yield in areas where overdevelopment has depleted the aquifer. The excess surface water is also conserved and stored for future requirements. So they use rainwater harvesting recharge for the building. So that shows the green building that used at the Tata Research Energy. Next is Earth. So the campus is equipped with Earth Air Tunnel (EAT) is proposed for the peripheral commercial block and the administrative block of the institute. This state-of-the-art air conditioning system, which is similar to a split AC, is highly efficient under partial loading conditions and beneficial to areas with varying occupancy. It allows customized control of individual zones, eliminating the use of chill water piping, ducting, and plant room. The use of earth air tunnel gives an energy saving of nearly 50% for cooling the classroom and labs. Involve storing energy when available and using it when required. This cool thermal mass is used to cool air in daytime. Okay, next we go through to the basic design vectors. So to integrate functionally of the building with energy application, to minimize energy demand in the building through architecture intervention. Example, passive concepts such as solar radiation, lattice work for shading, insulation and landscaping to meet the space conditioning and lighting demands through energy efficient system, to meet the electric energy demands using renewable energy resources. So the basic design vectors, they use solar lights used in garden, and another one is solar street lights at the campus. Next, for the few of the south-facing walls are mounted with aero screen louvers, Hunter Douglas. So we can see the picture of aero screen louvers that are slide. This ensures that the winter sun is let in whereas the summer sun is blocked. The use of louvers in front of the glazed walls also reduce the heating up of the glazed facade considerably. So for the walls that are exposed to the harsh solar rays have a stone cladding which is fixed to the wall by channels. The air gap between the wall and the stone cladding in itself acts as an insulation layer. One of the on the western facade, rock wool insulation is also provided in the wall. Energy efficient is further enhanced by vermiculite insulation in parts of the roof slab. So we can see at the picture vermiculite insulation that can put at the roof slab. So when the sun go through in the building, so the building is not hot at the building. So next, for the design features, we can see 4 elements. First, skylight. Number 2, polystyrene insulation. Number 3, China mosaic white finish. And number 4 is vermiculite concrete. So this is the 4 design features that can accept at the Tata Research. So roof insulated with vermiculite concrete and China mosaic white finish. Insulate wall using expanded polystyrene insulation, vermiculite concrete, China mosaic white finish, polystyrene insulation. Shading device and fenestration have been designed to cut off summer sun and let in winter sun. Glare-free daylights used through a specially designed skylight. The building design as such, wind direction can be regulated. Deciduous trees used in the south to shade the building in summers. In winters, these shades leave desolating in winter sun. Building oriented along east-west exists so as to have maximum exposure along north-south. South side particularly sunk into ground to reduce heat gains and losses. East and west devoid of opening are shaded. Okay, we go through to energy efficient system, EAT. So for EAT, we have 4 tunnels of 70 meters long and 70 cm diameter lay at a depth of 4 meters. 4 fans of 2 HP each force the air in a solar, force the air out of the rooms. Temperature remains 26 Celsius 4 meter deep in Gurgaon through years. Rooms cool at 28 Celsius when temperature is 40 degree during daytime in summers. In winter, temperature record was 22 degree when the ambient temperature was 10 degrees Celsius. Next, number 2, energy efficient lighting. So for this energy lighting, use energy efficient compact fluorescence lamps in the residential quarters, corridor, lobby and toilets. The conference room enjoy glare-free daylights through skylight. Time-based control switch off light at present time. They use a skylight that can give natural lighting in the space at the Tata Research Institutional. Next, number 3 is root zone system. Wastewater is recycled by root zone technique, in which the roots of premites plants with special capabilities of collecting the waste at the roots are used to clean the water which is used for irrigation. It cleans 5 meter cube of waste every day. For the water collecting system, water harvesting and watershed management are proposed in entire area. So they use these plants, paramites plants, that can give benefits for the green buildings. Next is renewable energy system. 24 hot water panel forms a part of parapet walls inclined at 70 degree instead of 45 degree. Fulfills the daily requirement of 2000 liters daily at 65 degrees Celsius. In winter, gas derived from burning twigs, dry leaf serve as a backup source to heat the water. Next is biomass gasifier system. As we can see, the biomass gasifier is the main source of power during the day part of full wood. The gazebo can also use straw, small twigs and branches, and other crop residue. To make such full easy to handle, it is chopped into small pieces which are pressed together to form compact cakes and briquette. The 50 kilowatt gazebo runs as a generator, whose DC requirement has been cut down to 30% after appropriate modification. The rest of the fuel comes from the gazebo in the form of producer gas. 1 unit of electricity produced needs 1 kilo biomass and 90 ml of diesel. We can see the biomass gazebo system is efficient that can use in passive building and green building. Next is photovoltaic panels. So solar water heater taps the sun energy directly. A series of photovoltaic panels capture the energy and store it by charging a bank of batteries. The panels can generate up to 10.7 kilowatt peaks of energy, which is fit into a 90 ampere hour or 240 volt battery bank. Independent panels power most of the light located outside the building. Each such light has a pair of small photovoltaic panels, roughly a meter wide and a half a meter tall, and it is a self-sufficient stand-alone unit. The sun is powering forth of retreat, where solar panels are used to form a solar roof. Photovoltaic panel also run a water pump. So photovoltaic panel is a solar panels that use at the top of roof at the Tata Energy Resources. Next, we go through to the acoustic. So for the acoustic, a dense fiberglass panel is one of the widely used material as bass strap, dealing with low frequencies of sounds. Number 2 is mineral wool is material for wall that can improve the soundproofing of a room. So we have two the acoustic that I found in the Tata Resources. So number is fiberglass window and the mineral wool. So this is the acoustic that can give advantage for the passive and green buildings. So the last but not least, I have made a comparison between base building and passive building. So we can see the passive building is 80% we can use and more efficient in right now in the world right now can be used. So the range between base building and passive building is very different, about 90% between us. So we can see the heat loss comparison between base building and passive building. The passive building is more efficient that I can use. Another one is a comparison is about energy consumption comparison. So for the base building and passive building, we can see the base building is more highly between passive building. This shows that the base building is non-efficient in right now. So for my suggestion, the element that used in Tata Energy Resources Institute theory, like energy efficient lighting, energy efficient system EAT, biomass gazebo system can give some advantage to other people or institutional building. Tata Energy Resources Institute also can give healthier for people living in it. Passive solar energy help Tata Energy Resources give very cost efficient way to take step towards sustainability. And the last one is comfort improvement in Tata Energy Resources Institute. For my conclusion is, for my opinion, Tata Energy Resources Institute building conveys skillful interplay of natural elements with the building form to reduce energy demand. So for my reference, you can see at the picture given at the slide given with the Wikipedia, the Energy and Resource Institute, and three more reference that I have made. So that's all for me. Thank you very much and see you for the next video.